All right. So, we have had we have some DNA resembled by these cords, right? Obviously, DNA is a double helix, but for the purpose of explaining replication, it is not a double helix. It's gonna be like this. So I'll show it on paper though because it kind of like flops around on the desk. But I'll do a little bit of a key for the items I'm about to use. Okay. So we have here our helicase. This is our primase that's going to polymerize a short RNA primer. This is the DNA-dependent polymerase that's going to synthesize the DNA. Here we have the autocluase, which is going to remove the RNA primer. And then we're going to go back here to our DNA-dependent, and then eventually we have our ligase. And then I'm going to use this bananagram set as to like show the DNA strand in better detail. All right, so going from the beginning, DNA forms a double helix. So let's just show our DNA as it normally is here. All right, so this is DNA. All the nucleotides matched up. And you can imagine there's a backbone on this side too. But what's going to happen is that helicase is going to come in, like right here. It's going to come in here. Say there's two of them. And they're going to work, one's going to work this way and one's going to work this way. And what's going to happen is they're unzipping the DNA. And so you're going to kind of get this little hole. This is really hard to do as I like look through the camera, but this is the little hole that helicase is getting. So as it continues, imagine the string continues here. As it continues, it's going to create an even bigger hole, right? It's unzipping the DNA. All right. So let's just toss this aside. Let's focus on one part of the replication fork here. So after helicase is unzipped, part of it, what's gonna happen is, and this is the leading strand, just to make that clear. So after leading strand synthesis, a DNA-dependent DNA polymerase is going to polymerize the leading strand. But in order to do that, we need a primer. So the primer is going to come in. This like not so great tomato is going to come in, and it is going to create a primer. So it's an RNA primer though. So this is going to be a U. Or sorry, this is going to be U. And this is going to be an A. Right? So we can imagine, I'm just going to straighten it out. The video. There's an A, and then, maybe there's a G, right? So the primer's going to come along, going to create this like little primer. But the problem with the primer is that it has a U, right? It's RNA. And so this is not going to work later on, and we'll see what goes on. But first, this primer comes in, and then after the primer comes in, you have the DNA-dependent DNA polymerase, which is going to actually make the new strand. So this piece of gum is going to come in, and it's going to continue. So here we go. It's going to come in after the helicase, right? So it's coming in this way. It's going to lay down a T. It's going to lay down a T. Da, 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 da. Right, continue. So let's just say this is like way over here. It would continue working, where'd it go? Over here, going through, and this works out, or sorry, I made a mistake. It's coming this way. It's laying down this one first and this one first, and this works out really well because as helicase is kind of coming this way, the leading strand is able to replicate pretty much in line with it. It's a very effective and efficient means of replication, is going with the helicase or helicase. Okay, so let's put it back. All right, so the next thing that happens is we have this issue, right? We have a U and we have a T, and that's not gonna work. And so on to glucose, I'm definitely butchering that. It's gonna come through and it's going to fix the issue here, right? So it's gonna get rid of that U. It's gonna get it out of here, right? Bye. So that's gone. And then DNA-dependent DNA polymerase is going to add in the missing nucleotide. So it's gonna come through and uh-oh, let me add a T here. Let's add a T, here we go. It's gonna add a T. Nice, we just fixed it, cool. But because we had cut it out and put a new one in, we do have an issue with our backbone. There would be like a cut right here, right? And that's not gonna work. So what's gonna happen is ligase is gonna come through, this T packet, and it's going to fix the backbone. So this is ligase coming through, kind of like repairing the DNA, but really it's repairing the backbone and that cut. And so I'm just gonna like mend it, I guess, kind of make it all look the same, strengthen it up. There's no cut anymore. Now it's the whole strand. And so that's really leading strand synthesis. But then lagging strand is a little bit different. So let's go back to kind of how we were. You can imagine this was the strand, right? And here helicase is unzipping. Well, the lagging strand, you know, before we have DNA polymerase just kind of coming along with helicase, the lagging strand's actually going this way. So before, when we looked at DNA polymerase coming through, it was going from the 5 to the 3' end. And it will always do that. However, when you're over here, or not over here, sorry, when you're on the lagging strand, it's a little different. And it's actually, the 5' end is starting here and it's going this way. And this is a problem because helicase is going that way. And you're going this way. And so every time it starts, you know, it's behind. As soon as it starts, it's behind. And so you have these segments that you're going to start creating. So it's going to polymerize. We have DNA polymerase. It's going to polymerize lagging strand. It's really the same set though. So first we have the primer coming through. So you're going to have A, G, C. You know, remember that when you have RNA, you have a U somewhere. So let's just say there's a U over here. This is the RNA primer that's coming through, but the primer's kind of a problem, but you have DNA coming through. It's going to finish off the strand over here. But, you know, there's an issue. So even though it's finishing off this strand, let's finish it off here. We still have an issue, and so what's going to happen is we have onclase, which is going to come through. It's going to fix it up. It's going to get this U out of here. The enabler is going to come back. It's going to fix it. So let's say it fixed it. I'm just not pretending it's there. And then we have the backbone getting fixed again. So that's basically what's happening, but the biggest part is that it's all happening in segments. So ligase is coming and fixing the backbone, right? But this strand is now behind, and so what you have is this gap between helicase and the strand that has been replicated. And so let's just say you would have like, okay, I'm totally out of letters here. Like another one, right? And so you have more that you need to replicate. But now you're over here replicating, going the wrong direction. And so you have primase, which is gonna polymerize a RNA primer is gonna come through and it's gonna come over here, right? So as soon as helicase is over here, this is weird, my finger in it. It's gonna come over here. Let's turn the paper over a little bit. Very low budget. Here we go. So here we go. Primer is coming over here. Helicase is going down, going down, going down. It's going pretty quickly. Primase is here. It's gonna start a new strand, so it's gonna lay down the primer. Let's say the primer is 2 nucleotides this time, just because I'm out of letters here that would match. So it's gonna lay down the primer, and then we are going to continue the strand again, and it's gonna come through, and it's going to replicate that strand. But what's gonna end up happening is you're gonna have this new strand. So let's just say you have just, I'm just gonna use normal letters, you have just created a new strand here, and you have fixed it as well. So I'm just gonna turn that over. So we have this perfect strand, and this is just because we have this perfect strand, but we have an issue because these are 2 separate strands. And so what now needs to happen is that we have to fix the backbone to make it 1. And so ligase is going to come in and it's going to fix it. And so it's 1, oh, there you go, complete DNA line here. And so we have the original template on the top, and we have the replicated template on the bottom, and then we no longer have it segmented. So that would be lagging strand replication and leading strand replication. And also it's important to note that there are multiple replication bubbles per stretch of DNA. So there might be a replication bubble here, and it's opening up, and maybe there's like another one over here. And what's gonna happen is helicase, 2 are going this way, another one was coming this way, and they're gonna run into each other, and that's what's going to completely open up the strands. So they're just 2 separate ones altogether. Another important thing to mention is that unwinding the DNA creates tension, and this tension, it needs to be, so I'll put it back on me. So what's going to happen is if when we go back to our DNA here, when we are winding it, there's quite a bit of tension. We can imagine if we are like pulling this apart, there's a lot of tension. And so to release the tension, we have an enzyme called topoisomerase, which is going to relieve that tension by cutting a strand of DNA. So it's kind of another thing to note. But yeah, that is how replication works in the leading and the lagging strand, and I hope that was helpful.